What is polar vortex? The polar vortex is one of those weather terms that suddenly explodes into public conversation when extreme cold hits. Flights are canceled, pipes freeze, and entire cities come to a standstill. It sounds dramatic, almost like something pulled straight out of a science fiction movie, but the truth is even more fascinating. The polar vortex is not a storm, it is not a single event, and it is definitely not something new. It is a massive, long-lasting atmospheric circulation pattern that has existed for as long as Earth has had an atmosphere and temperature differences between the equator and the poles. At its core, the polar vortex is a huge area of low pressure and extremely cold air that spins around the Earth's polar regions, both in the Arctic in the north and Antarctica in the south. This spinning motion is driven by Earth's rotation and the sharp temperature contrast between the icy poles and the warmer mid-latitudes. During much of the year, especially in winter, this circulation becomes stronger and more organized, forming a tight band of powerful winds high in the atmosphere that essentially acts like a wall, keeping the cold air locked near the pole. Most of the time, the polar vortex stays where people never notice it, tens of thousands of feet above the surface. When it is strong and stable, it behaves almost like a lid on a freezer, trapping the cold air near the Arctic. Life continues as usual in the mid-latitudes. Winters are relatively predictable, and the polar vortex never becomes a trending topic. But when that circulation weakens, stretches, or becomes distorted, things start to change dramatically. When the polar vortex weakens, it can wobble, split, or shift away from the pole. This allows pockets of Arctic air to spill southward into regions that are not used to such intense cold. That is when headlines appear about record-breaking low temperatures, snowstorms in unexpected places, and dangerous wind chills that can freeze exposed skin in minutes. It is important to understand that the cold air is not newly created. It has always been there. The difference is that the atmospheric barriers that normally contain it have broken down. One of the most misunderstood aspects of the polar vortex is the idea that it is coming to a place. In reality, the polar vortex itself does not travel south like a storm system. Instead, it deforms and allows cold air to escape its usual boundaries. Think of it less like an invading force and more like a protective fence that has developed gaps. Through those gaps, frigid Arctic air pours into lower latitudes. The polar vortex exists on two main levels of the atmosphere. One is closer to the ground, in the troposphere where weather happens. The other is much higher up in the stratosphere. The stratospheric polar vortex plays a huge role in shaping winter weather patterns. When the stratospheric vortex is strong, it reinforces stable weather below. When it weakens, it can trigger a chain reaction that disrupts weather patterns across entire continents. One of the key processes that can weaken the polar vortex is known as sudden stratospheric warming. Despite the name, this does not mean the Arctic suddenly becomes warm at the surface. Instead, temperatures high in the stratosphere can rise dramatically over a very short period of time. This warming disrupts the circulation of the polar vortex, sometimes even reversing its direction, and the effects can cascade downward into the troposphere over the following weeks. When this happens, the jet stream, which is a fast-moving river of air that steers weather systems, often becomes more wavy. Instead of flowing smoothly from west to east, it develops deep dips and sharp ridges. Those dips allow cold Arctic air to plunge far south, while the ridges can push warm air unusually far north. This is why polar vortex events are often associated not only with extreme cold in some places, but also with unseasonably warm conditions elsewhere. Another reason the polar vortex captures so much attention is its connection to climate change, a topic that sparks intense debate and confusion. It may seem counterintuitive, but a warming planet does not eliminate extreme cold. In fact, changes in Arctic temperatures can alter the behavior of the polar vortex. The Arctic is warming faster than many other parts of the world, reducing the temperature difference between the pole and lower latitudes. That temperature difference is one of the main drivers that keeps the polar vortex strong. When that difference weakens, the polar vortex may become more prone to disruption. This does not mean every cold snap is caused by climate change, but it does suggest that changes in the Arctic can influence how often and how severely polar vortex disruptions occur. This is an area of active scientific research, and understanding it is crucial for improving long-range weather forecasts. The impacts of polar vortex events go far beyond discomfort. Extreme cold can strain power grids, cause widespread infrastructure damage, and pose serious health risks. Prolonged exposure to low temperatures can lead to frostbite and hypothermia, especially for vulnerable populations. Transportation systems can grind to a halt, agriculture can suffer significant losses, and even ecosystems can be affected as animals struggle to adapt to sudden temperature swings. Despite how dramatic polar vortex events can be, they are not permanent. Eventually, atmospheric patterns shift again. The polar vortex re-strengthens, and cold air retreats back toward the pole. The challenge lies in predicting when disruptions will occur and how severe they will be. Advances in satellite technology, computer modeling, and atmospheric science have improved forecasts significantly, but the atmosphere remains a complex and chaotic system. Understanding the polar vortex also helps clear up a common misconception. A particularly cold winter in one region does not disprove global warming. Weather refers to short-term conditions, while climate describes long-term trends. The polar vortex operates within that broader climate system, and its behavior can vary from year to year even as global average temperatures rise. As you're watching this, it's worth thinking about how interconnected Earth's systems truly are. Events happening high above the Arctic can influence weather thousands of miles away, affecting daily life in ways most people never consider. The polar vortex is a powerful reminder that the atmosphere is not static. It is dynamic, interconnected, and constantly evolving. If you're finding this breakdown helpful so far, take a moment to like this video. It really helps more people see content like this, and it lets us know you want deeper explanations of complex topics without the hype. The polar vortex will likely continue to be part of our lives for as long as Earth has polar ice and seasonal temperature differences. What will change is how well we understand it, and how prepared we are to deal with its impacts. Better forecasting, stronger infrastructure, and informed communities can make a huge difference when extreme cold strikes. As science continues to advance, researchers are learning more about how the polar vortex interacts with oceans, sea ice, and even tropical weather patterns. These connections show that no part of the planet operates in isolation. A shift in one region can send ripples across the entire globe. If you enjoy content that explains the science behind the headlines and helps you make sense of the world around you, make sure you subscribe to the channel. New videos like this are coming, and you won't want to miss them. The next time you hear the term polar vortex in the news, you'll know it's not a sudden monster appearing out of nowhere. It's a complex, powerful atmospheric system doing what it has always done, shaped by natural forces and influenced by a changing planet. Feel free to share this video with anyone who's ever wondered why winters can suddenly turn so extreme. Knowledge spreads best when it's shared, and you might be surprised how many people are curious about this topic once it's explained clearly. Thanks for watching all the way through. Stay curious, stay informed, and we'll see you in the next video.